So, hi everyone. In today's class, we are going to discuss about basic of probability. Basically, probability is a part of statistic, and if I am talking about statistic is a part of mathematics which deals with data. Means what? Like it provide answers answers of the problem. When I am saying answer means what? Relevant information to a problem from a given data on the basis of some analysis, on the basis of some testings. So today we are going to discuss about the probability. So let us firstly try to understand what we mean by probability and what exactly it is and how one can calculate it. So if I want to give you simple definition of probability, so it tells about the chance of happening an event. It tells about the chance of happening an event under under some under some conditions. When I'm saying under some condition means what? There's many terminology related to the probability that I will discuss later on. So it tells or it gives you the chance of happening an event. So one can also say that probability is the numerical measure of uncertainty. It measures the uncertainty of an event. For example, when I am tossing a coin and I am saying what is the chance of getting head, what is the chance of getting tail. So this is what it tells us, what is the chance of getting head in the event, which is what? Tossing a coin. In the same manner, when I'm throwing a dice, what is the chance of getting a number 2 on the top face of the dice? In the same manner, 3, 4, or 5. Some more general example, like many times we hear the news, like tomorrow there will be a rain, the chance is 80%. There's 80% chance, there is 80% chances that tomorrow is rainy day. What it means? It means what? It tells us that there are 80% chances that it may, that if we are considering the same kind of day, so out of 100 times, 80 times it will be rainy day. Okay, this is what we are having the basic definition of probability. Now, there are many definitions given by different statisticians related to the probability. As we have already discussed, one of the definition, the numerical measure of uncertainty of an event is known as the probability. The degree of uncertainty, the degree of uncertainty about happening of an event is known as the probability of happening of that event. It is a science of decision making under calculated risk. It is also called as the science of decision making with the calculated risk. Why the term use calculated risk? Because we already know in advance that what is the chance of success or failure for that particular event. Now, before moving to the standard definition of probability, let us talk about some of the basic terminology. The one that we are having is known as a random experiment. So the first thing that we are going to discuss is what we mean by a random experiment. So when I'm talking about a random experiment means what? An experiment whose outcome is not unique. A random experiment is what? An experiment whose whose outcome, whose outcome is not unique, is not unique, is not unique, but one of the possible outcomes. One of the possible outcomes. An experiment is said to be random experiment if we didn't know in advance that what will be the output. For example, if I'm throwing a dice, I cannot say that what will be the number top on the dice, but I'm sure that it is 1, 2, 3, 4, 5, or 6. So whose outcome is not unique, but one of the possible outcome. Like one of the possible outcome means what? When I'm throwing a dice, in that case, the possible outcome will be what? It is 1, 2, 3, 4, 5, 6. This is what the possible outcomes. This is what the possible outcomes, and this is known as the exhaustive events. These are known as the exhaustive events. So this is what we are having a random experiment, and this is what we are having exhaustive events. Exhaustive events, that is the set of all outputs is said to be the exhaustive events. Moving ahead, there's a one another term that we are having which is known as the favorable event. Favorable event. So favorable means what? Out of exhaustive events, how many outcomes are in the favor for a particular event? For example, like throwing a dice, and I'm saying the event is what? Getting 2. So getting 2 is this one. So this is our favorable event. If suppose that I define the event as sum should be 5. Sum or sum should be 5. For that we need to take 2 dice. We'll take that later on. I can say like my random x, I just throw a dice, and now I am the event that I'm going to take is what? The even number. So in the case of even number, the favorable outcome will be 2, 4, and 6. 2, 4, 6 are what? Favorable outcomes. So this is what we are having favorable outcome. Another term that we are having is what? Mutually exclusive outcome. Now means what? Before giving you the proper definition of probability, now we are going to discuss some basic terminology related to the probability. Exhaustive events or sample space, as I already discussed with you, the total possible outcomes in a trial is known as the exhaustive events or sample space. And out of those, each outcome is called a sample point. So if someone is asking what is a sample, if someone is asking what is a sample point or what is a sample space, so what will be our answer? Our answer is what? Sample space means the collection of all the outputs of that random experiment. For example, in tossing a coin, what will be the exhaustive events or sample space? It is head and tail. It is head and tail. In throwing a dice, the sample space, as already discussed, 1, 2, 3, 4, 5, and 6. These individual 1, 2, 3, 4, 5 called what? Sample points. Another important terminology is mutually exclusive events. Mutually exclusive event. So two events are said to be mutually exclusive when the occurrence of one of them exclude the chance of occurrence of others. Mutually exclusive means what? Two events are said to be mutually exclusive if occurrence of one exclude the chance of occurrence of other. Or we can say that the event which can't occur simultaneously. The events which can't occur simultaneously is said to be mutually exclusive event. For example, in tossing a coin, if suppose that I am taking two events, one getting head, another getting tail. So these two are mutually exclusive event. Why? Because if I get head, then tail excluded, and if I get tail, head is excluded. One more example, you can't run backward and forward simultaneously. Like if I'm taking two events, one moving backward, another moving forward. So these two are also mutually exclusive event. Rain and sunshine. What did you think about rain and sunshine? Are they mutually exclusive? Obviously, no. Why? Because many times we observe that there's a raining as well as sunshine. So, raining and sunshine are not mutually exclusive events, are not mutually exclusive event. Another, we are having equally likely events. So the events are said to be equally likely if one of them cannot be expected in the preference of other. Two events or more than two events are said to be equally likely, as the definition also reflecting. Equally likely means what? The chance of happening of both the events is same. For example, getting a head and getting a tail is equally likely event, because we know that if we are taking ideal condition, getting a head or getting a tail is having the same chance of occurrence, like 50% and 50%. So this is what we are having equally likely event. Let us take some more example. If we draw a card from a well shuffled pack, we may get any card, then 52 different cases are equal likely. Like out of 52 card, what is the chance of getting this card? 1 upon 52, 1 upon 52, and in the same manner. So each of them is having the same chance of occurrence. So we will call them as equally likely event. One more example for clarity. Suppose that I am tossing a dice. So P is the event of getting an odd number and Q is the event getting a number 5. So what did you think? Are they equally likely? What is the chance of getting an odd number? So if I am talking about a dice, so sample space is 1, 2, 3, 4, 5, 6. Now getting a odd number. Getting a odd number. So what is odd number here? 1, 3, and 5. As we know, the probability is what? We are having favorable over sample space. The number of favorable event upon sample space. We'll see this definition also in the coming slide. So favorable, we are having 1, 3, and 5. So it will be 3 upon total 6. Now getting a 5, only one favorable, so probability is 1 upon 6. Since their chance of occurrence is not same, since their chance of occurrence is not same, so we will say they are not equally likely. They are not equally likely. Can I say that they are mutually exclusive? Yes, think on it. Are they mutually exclusive? Obviously, no. Because if I get 5, then both the event occur simultaneously. If I get in a throwing a dice, if I get 5, then P and Q occur simultaneously. But as the definition says, mutually exclusive event, will never occur simultaneously. Now, I hope you understand the difference between equal likely and mutually exclusive. One more example is there. If P is getting a prime number, Q is getting an even number. So, prime number and getting a even number. So, prime number and even number, what is even number? It's 2, 4 and 6. So, 2, 4, 6 means 3 upon 6. And getting a prime number, only 2 is a prime here, so 1 upon 6. They are not equally likely, but are they mutually exclusive? No, because if the number 2 comes as the output of that event, then P as well as Q occur simultaneously. P as well as Q occur simultaneously. Moving ahead, another thing, independent event. So there's a note, mutually exclusive and equally likely events are distinct. They are not the same thing, as it is clear from the definition also. Another, we are having independent event and also known as disjoint event, or I will take that in the later on. Independent event. Two events may be independent when the actual happening of one does not influence in any way the happening of the others. Two events are said to be independent if happening of one do not have any impact on happening of other. For example, a coin is tossed 2 times. Suppose I am taking P is the event getting head in the first chance and Q is the event getting tail in the second chance. Now suppose that in the first chance if I get head, so is it effect to get head in the second chance? Obviously no. So these two events are said to be independent event. Moving ahead, example, the event of getting head on a first coin and getting tail on the second coin in a simultaneous throw of 2 coins are independent events. Favorable, as I already discussed, what are the favorable events? The number of cases favorable to an event is called the favorable events. Now coming to the definition of the probability. Why I take the basic terminology so that this definition will be clear to you. Now what the definition is saying, if there are n exhaustive, mutually exclusive and equally likely cases. Very important here, we are conducting a trial, a random experiment, an event in which we are having exhaustive, exclusive and equal likely cases, out of which n are favorable and n are favorable of an event, then it's not n exactly, it's m, equal likely cases of which m are favorable and n is the total sample space. So the probability of happening event will be what? Favorable number of cases divided by exhaustive number of cases. Favorable number of cases divided by exhaustive number of cases, and this is the case when the event or the cases are mutually exclusive, equally likely and exhaustive. Exhaustive, mutually exclusive, equally likely. Then this definition will be applicable. Exhaustive number of cases means what? It is nothing but sample space. Favorable number of cases means what? How many events are there in the favor from the sample space. From the sample space. So this is what we are having a definition of probability. So let us take some example. I am started with the very basic example. What is the probability? What is the probability that a leap year, what is the probability that a leap year is having 53 Sunday? Very basic example. Many of you already heard the example also. The question is what? If a year is selected randomly, a leap year is selected randomly, what is the probability it is having 53 Sundays? So now, what did you think on it? When I'm talking about leap year, so a year is said to be leap year when the thing is that the number of days it is having is what? 366 days. The number of days in a leap year is 366. If it is having 365 days, it will count as a non-leap year. 366 leap year. So it is having 366 days. Now they are talking about 53 Sundays. So as a common sense, if today is Sunday, the next Sunday comes after 7 days. Getting it or not? After every 7 days, a day is repeated. So when I divide it by 7, what I will get? Or I'm going to find the number of weeks. Number of weeks. It will be 366 divided by 7. So 7 5 35, 7 2 35, 7 2 14 plus 2. So we are having 52 plus 2 days. So 52 weeks plus 2 days. Total 52 week will be there in a leap year and 2 days is there. So now 52 week means every day is at least 52 times, be that is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or whatever the day we are talking about. Now the case is what will be these 2 days. So let us decide the sample space on the basis of these 2 days. So these 2 days may be Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday, and Sunday, Monday. So this is what the sample space for these 2 days. 1, 2, 3, 4, 5, 6, 7. So this is our sample space. Obviously, it's not like out of these 2 days, both of them is Sunday. Not possible. Why? Because it's not like Sunday today and tomorrow is also Sunday. Okay, so this is our sample space. So now what will be the probability? So the probability, we know that favorable number of cases divided by sample space. Now, sample space is how much? 7. So now how many favorable? 52 Sundays already there. Now I need to make 53 Sunday. So the pair should be either Sunday, Monday or Saturday, Sunday. The 2 days that left after 52 weeks should be either Sunday, Monday or Saturday, Sunday, because it will count 53 Sundays. 52 is already there and 1 comes from here. So these 2 are the favorable space. So finally what I am getting 2 upon 7. So the probability that a leap year selected randomly will have 53 Sunday is 2 upon 7. 2 upon 7. Or if I want to calculate it in the decimal, so 0. This will be how much? 7 to 14, 28. Almost 0.28%. So 28% chances are there that a leap year selected randomly will have 253 Sundays. Now, if the question is asking 54 Sunday, what can you say in that case? 54 Sunday. So sample space is same, but 54 Sunday means that 2 days that left must be both of them Sunday, which will not possible because it is not Sunday. So probability of 54 Sunday is 0. If someone is asking what is the probability of 52 Sunday, so it's 1. 100% it will have 52 Sundays. So this is the case that I have taken for a leap year. But on the same time, if the year is not a leap year, the question is look like what is the probability that a randomly selected year will have 53 Monday or Sunday, doesn't matter. But we are talking about non-leap year. So number of days in a non-leap year is how many? Number of days in a non-leap year is what? 365. So what will be the number of weeks? So the number of weeks will equals to 365 over 7, which will be make it as what? 52 plus 1 day. So it will have 52 times every day, Sunday, Monday up to Saturday. So 1 day left. So what will be the sample space? This 1 day will maybe Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So this will be sample space, and favorable is what? This is the favorable one. So the probability will comes out as 1 over 7. So if a year is leap year, the probability is 2 upon 7. Non-leap year, 1 upon 7. So this is how we can find the probability of happening some event. Let us take some more example. Suppose that a dice is thrown, and E is the event, like we have made E is the event that number is divisible by, let us take by 3. Means we are random experiment is or throwing a dice, and E is the event that the number is divisible by 3. So what will be its probability? What will be the chance that in throwing a dice, whatever the number comes on the top will be divisible by 3? So let us try to find it. First, what we will do? The first thing is that we will write the sample space. So when we are throwing a dice, the sample space will be 1, 2, 3, 4, 5, 6. So these are the output, or we can say the sample points or the exhaustive events. Now, what is the favorable events? So the favorable event will be what? It will be divisible by 3. So either it should be 6, 3, either it should be 3 or it should be 6. These are the favorable event. So now the probability that the number is divisible by 3 will be what? Favorable events over sample space. So 2 favorable is there, 3 and 6, sample space 1 to 6. So 2 upon 6, which gives you 1 upon 3. So 1 upon 3 means what? 0.33. So this is the chance that when a dice is thrown, you will get a number which is divisible by 3. I hope you got the clarity on this example. One more example. Now suppose that in place of one dice, I am throwing two dice simultaneously. I'm having two dice, throwing them simultaneously. Now I need to know what will be the probability that some on the dice, some on the top of two dice will be less than 5. Means we can make many example likewise. Now, if I'm talking about throwing a two dice, so what will be the sample space first? In throwing a two dice, the output will be like what? 1, 1, 1, 2, 1, 3, 1, 4, and the same manner divide 2, 3, and so on. So there is an easy way to list it all the output for the sample space. We can make a representation in a terms of a table. So if I am talking about output, it may be 1, 1, it may be 1, 2, it may be 1, 3, 1, 4, 1, 5, 1, 6. In the same manner, it may come out as 2, 1. It may come as 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. In the same manner, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So how many entries are there in total? This will be 6 into 6, so 36. So the sample space in case of throwing two dice is 36. And what is our event? The event E we had defined as sum is less than 5. Sum is less than 5. So what will be the favorable over here? 1, 1, yes. 1, 2, yes. 1, 3, yes. Can I take 1, 4? No. Because 1, 4 make it 5, which is not less than 5. In the same manner, 2, 1, it will be 2, 2. Yes, but 2, 3 will not be there. In the same manner, 3, 1 is there, 3, 2 not there, 4, 1 not there. So this will be our favorable event. So how many favorable? 1, 2, 3, 4, 5, 6. So what will be the probability? Favorable over sample. So 1 over 36. 6 over 36, which gives you 1 upon 6. So 1 upon 6 is the probability that when two dice thrown simultaneously, you will get a sum less than 5. In the same manner, it can be like what is the probability that both the dice top give you the same number? So that will be what? 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So this will be your sample space divided by the total. What will be the probability that sum is greater than 12? What will be the probability that sum is greater than 12? Think on it. Obviously, like when two dice is thrown, the maximum sum that you will get is 12. And we are talking more than 12. So favorable will be 0 upon 36, you will get it as 0. So this is what we have taken some example to make you understand that what exactly probability is and how to calculate it. Let us summarize the things that we have done till now. We have talked about what is probability. So probability is what? It is the numerical measure of uncertainty related to some event. Now we are having some terminology like random experiment. Then we have talked about the favorable event, mutually exclusive, exhaustive, and then the definition, or better to say the classical definition of probability. It says that if we are having a random experiment whose events, whose outcomes are exhaustive, mutually exclusive, and equally likely, then the probability is what? It will be favorable space over sample space. Magnitude, this is what mod means. It is not mod magnitude. It tells us the number of element it has. It tells us that the number of element it have. Okay, so this is what we are having about the probability. Now, there are some note that we should take from here. It is what? If probability of an event is zero, what it means? Already discussed, an impossible event. So, E is an impossible event. Impossible means it will never happen. If I'm getting probability of an event is 1, it means it is a certain event. It is a certain. Certain means there is a 100% chance that it will happen. And the value of probability for any event will always lies between 0 to 1. Why? Because just see here this definition, the favorable event can't be greater than the sample space. At most it is same as the sample space. So at most case means when favorable and sample is same, you will get it as 1. When there is nothing common between favorable sample, you will get 0. Otherwise, in rest of all the cases, it will lies between 0 to 1. It will lies between 0 to 1. It will lies between 0 to 1. One more thing, if we are having an event, so happening of this event and not happening of this event gives you 1. Happening, non-happening gives you 1. That we can say, what is the probability of E? 1 minus probability of not E. If we are denoting generally happening for P, not happening with Q, so we will write it as P plus Q equals to 1. Some standard notation. So this is what we are having the probability, or how to know that what is the chance of happening an event can be calculated by using this definition. Let us take some more example. So this is another example. A bag contains 8 white and 6 red balls. Find the probability of drawing 2 balls of the same color. Now here we should use the concept of permutation and combination. So permutation and combination means what? When suppose that there are n objects, and we need to select R. We need to select R out of them. So the number of ways R can be selected is NCR, and it is known as the combinations. How to calculate it is factorial n over factorial R over n minus R factorial. On the same time, if I need to arrange R objects, like when order matters, then it will be NPR. Permuting R object on n places, it is what? Factorial n over n minus R factorial. When you need to select, you should use the combination. When you need to arrange, you should use the combinations. Permutation, sorry. Combination. Selecting means combination. Arranging means permutation. Like suppose that I need to arrange two things on the two places. Two things on the two places. So number of ways, A, B. If it is first place, it is second place, or B, A. So two things, if they are not identical on the two places, it will be in two ways. On the same time, if out of two, I need to select two, only one way. So selection means order does not matter, and arranging means what order matters over here. So this is what we will use in the coming example, this example. Now I need to select how many balls. So firstly, total balls is what? 8 plus 6, 14 balls. And I need to select two balls. So sample space will be 14C2. Now use the formula and you will get it like this. Now they are asking it should be of same color. So they may be both white or they may be both red. So for both white, it is what? 8C2. Two white balls. Find the probability of two of the same color. So this will be what we are getting 8C2. So two white balls probability will be 28 over 91. It may be like two red is also possible. So 6C2, its probability will be 15 over 91. So the task can be done either two white or two red. So whenever we get or, it will be the addition. So 28 over 91 plus 15 over 91. So the total probability is 43 over 91. So this is how we get the answer for this question. This we have already done. Question number 3 is as for your homework. Two dice thrown, find the probability, both dice show the same color. The difference is even number excluding 0. Sum is less than 12. So think on this example. So this is all about the basic of probability and some examples. In the next class, we will take some more examples on the probability and we'll talk about laws of probability. So that's all from my side for the class. Now going to close it. Thank you. Thank you very much to all of you.